Hey guys, welcome to Conceptual Geometry, lesson 4.3. We're going to continue with more line reflections. Today what we're going to do is we're going to start reflecting over given lines or equations of lines. So I want to review vertical and horizontal lines quickly. The equation for a vertical line is always in the form x equals some number. For example, if I sketch in this line right here, that equation is x equals 2 since it crosses the x-axis right here at 2. And every point on this line has an x-coordinate of 2. 2, 1, 2, 2, 2, 3, so on and so forth. Well, a horizontal line then would have the equation y equals some number. So if I sketch in this line here, that would be y equals -1 because every point on this line has a y value of -1, -3, -1, -1, -1, 2, -1, so on and so forth. Okay, so now that we know that, in this example here, I'm going to take triangle ABC, and I want to reflect it over the line y equals 1. So the first thing I need to do is sketch that line in, y equals 1. Well, it's going to be a horizontal line where y is equal to 1. Okay, so let's put that in here. I generally like to make these dashed lines, but you don't have to. I just don't like to confuse them with the axes. So there's the line y equals 1. And if I need to reflect this triangle over this line, it's going to reflect down here. So what I'm going to do is I am going to count the distance from this point to the line and then go that same distance to the other side. So 1, 2, 3, 4, 1, 2, 3, 4. A prime would go right here. Okay, so let me put that in. 1, 2, 3, 4, 1, 2, 3, 4. Here's A prime. I'll do the same thing with C. That distance is 3, so I need to go 3 in that direction. So that point goes here. There's C prime. And then B, I would count 1, 2, 3, 4, 5, 6 to the line. 1, 2, 3, 4, 5, 6. Beyond it, that would be B prime. And then fill in the sides. Now what we need to do is we need to write those coordinates. I like to do transformations visually, but we always need to write the coordinates down. So we'll start with A prime. Coordinates here would be -3, -3. Okay, so let's write that down. A prime is -3, -3. B prime and C prime. Let's get those coordinates. So B prime is here. It looks like that's 1, -5. Okay, let's write that in. 1, -5. And C prime is here. It looks like that's 3, and that's -2. 3, -2. Okay, well, the next part here, it says reflect triangle ABC. Well, that's the original one, because now there's two triangles. I could start with either one of those, but I'm going to take this triangle here, and I'm going to reflect it over the line x equals 1. Well, that's going to be a vertical line right here, where the x value is 1. So let me sketch in that line first. All right, I don't need to go beyond that. You'll see why here in a second, but that's x equals 1. And now let's reflect our points. So here's A. I have to count the distance from A to the line of reflection, so that's 4. I need to go 4 on the other side. So a double prime, or in this case, notice they want us to use P, Q, R. So A will go over here and it'll become P. 1, 2, 3, 4. Right there is P. Oops, doesn't have a prime. Sorry about that. Just P. Now what's interesting is that B is on the line of reflection, so it doesn't go anywhere. Its image stays right there. So that point stays there, and that'll also be a Q. And then R is the reflection of C. So C goes 2 to the line. They have to go this direction, so right there is going to be R. Now when you sketch in the sides, look at what happens. This triangle overlaps that line of reflection. Okay, so I'll write the coordinates down over here. P, Q, R. Point P looks like if you look at the coordinates here, it's 5, 5, 5. Point Q is 1, 7. It's the same as point B. And point R is negative 1, 4. Okay, so there's an example where we reflected the triangle over a y equals line and then an x equals line. Okay, well, what if the lines aren't vertical or horizontal? Then we're going to use our old friend, the slope-intercept form. Remember this? Y equals mx plus b, where m is slope. And I want you to think of slope as rise over run. And remember, if your slope is positive, that's an uphill line, looks like that. Or if your slope is negative, that's a downhill line, looks like so. And B is called the y-intercept. It's where the line crosses the y-axis. So if I want to sketch this line over here real quick, y equals 2x plus 1, I have to label a couple things. Number 1, I know my slope is 2 over 1. And I don't normally write this out, but I'm just going to remind you guys. That means up to right 1. I know my y-intercept, or my b value, is 1. So what I do on the axes, I go up to 1 on the y-axis, put a point, and I go up 2 over 1, up 2 over 1 until I can't go any further. And then I reverse it. So go back to the y-intercept, and instead of going up and to the right, I go down and to the left. Because obviously it's a straight line, you have to continue that. Then you just connect those. Okay, there's that line. So now, let's graph the line y equals 1/2 x minus 3. So my information here, slope is 1 over 2, and your y-intercept this time is negative 3. So I'm going to take my time and do a good job graphing that. The y-intercept is negative 3, so I'm going to put a point there. And if your slope is 1 over 2, that means up 1, right 2. So look how many points we can get here. From my starting point, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, all the way to the edge. Then I need to reverse it. Down 1, left 2, down 1, left 2, down 1, left 2, all the way to the end. Now, if you don't have a straight edge, that's okay. That's why we put in so many points, because it's easier just to connect them if they are close together. I do not have a straight edge, so I'm going to just be as neat as I can here. Boom. Got it. All right, so that's part A. I might just write A here to indicate that's that equation. Now it says reflect that line over the y-axis. Here is your y-axis. Now, what's nice about these lines, you think, oh man, I have to reflect all these points. This point's going to stay. This point here goes 2 that way and then 2 that way, ends up being reflected right there. So I'm going to use a different color. That goes here, that point stays. And this point here gets reflected over there. So now look at the 3 red points. Remember, this is the line. So this slope here has to continue the whole way, kind of like stairs. So I don't actually have to reflect the other points as long as I keep that slope constant. And go all the way to the edge, and I just sketch that in. Put a couple arrows on it. I'm going to label that B, and that's good. Got it. Now this part's a little bit challenging. It says state the equation of its image. So basically I want the equation of this red line here. All right, well, what do we know? I know the y-intercept is negative 3. So B equals negative 3. Now how about our slope? This is what we're doing. Down and to the right, down and to the right, down and to the right. Down 1, right 2, down 1, right 2, down 1, right 2. So 1 over 2, almost. Remember, we're going downhill. We're going down into the right. So that slope is actually going to be negative 1/2. To write the equation, you just put those into that y equals mx plus b. Y equals negative 1/2 x minus 3. Cool. All right, let's wrap it up here with our 4th example. Actually, we got 2 more examples, but the 5th one is pretty quick. Graph y equals 2x plus 1. So what do we know? Slope is 2 over 1. I always like to write that as a fraction. My b value is 1. So my y-intercept is 1. Up 2 over 1. Up 2 over 1. I'm going to continue that pattern as far as I can and then reverse it. Down 2, left 1. Down 2, left 1. Down 2, left 1. Down 2, left 1. And connect all those. All right, so that's part A. Now it says reflect this over the x-axis. So here's your x-axis. This needs to get reflected. So this point here would get reflected down here. That point there gets reflected up here. Really, that's all you need. If you want to just verify with a couple others, that would go here. This would go there. But what's nice about it, again, remember, it's a line. So this point would go here. That point would go here. And then that one goes down. Once you get 2 or 3, right, here's what I did. Reflected that one, reflected that one, reflected that one over the x-axis. Notice, it's just the same pattern. Down 2 over 1, down 2 over 1, down 2 over 1, the whole way. So I'm going to continue that pattern all the way to the edge of the graph in both directions and then connect them. That's part B. And then lastly, again, I need to state the equation of its image. So what do we know about this line? There's my y-intercept. So b equals -1. Let me write that down. B equals -1. And then how about our slope? Down 2 over 1. Down 2 over 1. Since we're going down and to the right, our slope is negative. And it's rise over run. -2 over 1, or just -2, that's fine. So this equation will be y equals -2 over 1 x minus 1. And like I said, if you don't like writing 2 over 1, that could just be a -2, that's fine. I kind of like putting in the fraction because it reminds me it's rise over run. Cool. Last one. This one's kind of easy. It says, the graph of the figure ABCD and its image are shown below. State the equation of the line of reflection. So basically what we're doing is we are taking this shape here and we are folding it somewhere so it folds on top of this shape. Well, I think it's pretty obvious that you're going to fold it horizontally, right? You're not going to fold your paper here because then this shape would end up going over here somehow. So all we have to do is figure out, well, how far are these 2 points apart, D to D prime, right? So let's just count. 1, 2, 3, 4, 5, 6. So this distance here is 6. That means our line has to be halfway. 1, 2, 3. There's halfway. So if this is our line, this distance here is 3, and that distance there is 3, and that's exactly what I want. So now I'll draw that in. I went down 3. Right? You just have to check those two out. That distance is 3. That distance is 3. So this is my line of reflection. Since it's horizontal, it's got to be a y equals equation. And I'm crossing right here. It looks like that's -1. So that equation is simply y equals -1. There's your answer. Okay, that completes day 3. So now you have all the information you need to complete homework 3 on that work packet, or homework packet, I should say. You can find that on Schoology. If you lost your copy, or unfortunately you left school before I could give you the hard copy of that. But as usual, guys, if you have any questions, don't hesitate to reach out, and we'll see you guys soon.